Welcome to part 2 of this tutorial for Proteus 8.10. In part 1, I demonstrated how to select components and capture the schematic of a circuit design. Now we can use the Layout tool to create a PCB and position the components on it. Enter the PCB Layout suite by clicking the button at the top. This opens the PCB Layout pane. Again, you can zoom in and out by using the mouse scroll wheel. If your mouse does not have a scroll wheel, there are also buttons at the top. This is also true for the schematic capture window. The blue border represents the maximum size that a PCB can be made. If you have a preferred supplier and you know their PCB panel size limit, then you can set this border to represent that by going to the Technology menu, selecting Set Board Properties, and entering the maximum width and height. The units can be in IN for inches or mm for millimeters. We can switch between the schematic and the PCB layout using the tabs at the top. The components used in the schematic are given a designated code such as R for resistors, Q for transistors, D for diodes, and so on. Each designator is accompanied by an incrementing number as more of the same component are placed. In the Layout window, these components appear in the Selector pane. First, we need to generate the PCB. This is done by selecting the Draw tool and selecting the layer as board edge. When you draw the box, it appears in yellow, which is the default color for board edge. Just like in the schematic capture, to place a component, select it from the list, click once anywhere over the design pane, hover the component where you want to place it, use the number pad plus or minus buttons to adjust the orientation, and then click once more to place it. Do the same for all the other components. The board can be shrunk to fit by picking up the box and dragging it to the correct size. Now we need to connect the necessary pins together using copper tracks. Click on the Track tool. If automatic track style selection is enabled in the Tools menu, Proteus will automatically select the track width, depending on whether the track is carrying signal or power. You can deselect this option and manually select the track size as you go, but I'm going to leave it enabled and just go with the defaults for now. The green lines are called the rat's nest, and they show which pads need to connect together. As before, hover over a pad and it highlights. Click once to attach a track. Notice also that the projected route is shown for you. When you reach the destination pad, it also highlights. Click once more and the track is connected. The green line also disappears. Blue is the default color for bottom side copper tracks. These will run on the bottom side of the board. Red is the color for top side tracks, which will run on the top side of the board. You can switch between layers when placing tracks by pressing the spacebar. There is a 3D viewer which provides a basic rendering of what the PCB will look like. It can be accessed by clicking the button at the top. Click once to enter navigation mode. Moving the mouse will now rotate the view. The mouse scroll wheel can be used to zoom, and the buttons in the bottom left can be used to view from preset perspectives, and also show or hide the component models. You can see that the blue tracks in the design appear on the bottom of the board, and the red tracks appear on the top. So far the board is looking good, but we're not quite done yet. In order for the circuit to work in reality, it needs a power supply connection. Previously we simulated the circuit by adding power flags to the rails, but for the circuit to work in reality, we must make provision for a real-world power supply. In my case, this will be a simple wire connection, which I can provide pins for. Go back to the schematic window. Open the component manager, open the search and find a simple pin. Double-click and add it to the active parts list, and integrate them into the design. Set a label if necessary. I will label these pins as positive 5 volts and 0 volts so there's no mistake when connecting the power supply cables. Back in the PCB Layout window, the pins will now appear in the list. Place them on the board and connect the tracks. One last point I wish to cover before ending this tutorial. Power and ground lines can be replaced with copper planes. This is especially useful for noise shielding and current dissipation. The ground and power lines carry the cumulative current for the entire circuit. To prevent this from generating heat and noise, it's good practice to allow ground and power planes to carry this current, as they have much lower resistance and inductance. Go to the Tools menu, Power Plane Generator, select the net to attach it to and the layer, bottom or top. In this case, I will have the 5 volt supply carried by the top side plane and the ground on the bottom side plane. Once these planes are in place, any tracks which were carrying these signals can be removed. You now see that all the empty spaces on the board are flooded with copper, which is connected to the respective power nets, plus 5 volts on the top and ground on the bottom. In the 3D rendering, you can see that the 5 volt power connections are now tied to the top side plane, and the ground connections are tied to the bottom side plane. Once you're happy with the PCB design, it can be exported in Gerber format to send to the manufacturer. Exporting files involves a number of steps, and so will be covered in a separate tutorial. That concludes this basic overview of Proteus version 8.10 and its use. If you found it useful, please subscribe, as I will be releasing additional tutorials covering further features with more complex circuits in the future.